So as Ashish mentioned, thank you, Ashish. The topic is about the UIM and DXOI, basically DXOI connectors, the integration between UIM and DXOI. So we are going to I'm going to walk you through the best practices to deploy connector probes, APM bridge and OI connector, and the memory recommendations. Um, the third point is split of origins across different profiles, especially for APM bridge. I'll explain what it is and the time to live settings for APM bridge and why it is important. So in some of the end user environments, we observed that both APM bridge and OI connector are deployed on primary hub. So though this is a supported configuration and it's working as expected, in case if there is a huge good amount of data coming from the inventory probes, especially like VMware, AWS, and in-house subnet discoveries pumping huge amount of inventory data, let us say some 15,000 devices in 10 to 15 minutes of intervals at peak hours, especially when deployments are, cloning of templates are being happening and there are huge amounts of disks being added, removed, network adapters being added. There is a lot of inventory, monitoring happening in the backend, and there is good amount of data. In such cases, where the inventory is quite frequently getting updated at some point of time, uh, we recommend to have APM bridge and OI connector on dedicated robots connected to primary hub, but not on primary hub. So doing that would actually ease out the things and make the working conditions of the both these connectors little smoother. So what are the configuration options to deploy the both APM bridge and OI connector on remote robots connected to primary hub? So basically there are three important parameters for OI connector especially. One is the data engine address, the primary hub address, and the connect to primary hub parameter. I'll just show you where exactly they are so that you get an understanding. So if you see here, so this is the OI connector probe. Just a second. So this is the OI connector probe where you can see the raw configure section, and this is connect to primary hub parameter, which is by default set to true. But the important thing is when you deploy the OI connector on a robot connected to primary hub, it is important to specify data engine address, because OI connector depends on data engine address to issue a database connectivity during startup initialization phase, fetch the details from the database, and fill the cache. So to do for this to happen successfully, you need to one must specify the data engine address properly, which is obviously the primary hub where the data engine resides. The third parameter in discussion is the primary hub address itself. It is one of the configuration parameter which needs to be set. So within the setup section, the primary hub address will be available, which we need to set. Similarly, just a second. Similarly, if the OI connector by chance you have a, let us say, uh, instead of robot connected to primary hub, there is a situation where the OI connector is deployed on a secondary hub machine because you have some proxy, and DXOI can only talk from can be connected via secondary hub, so that it can talk so that acts as a proxy machine. Basically, it's like a a different subnet, and where you have a set of bunch of different devices, remote devices, which are being monitored by NetConnect or some other probes, remote probes, and you and there is a use case you need to deploy it on the secondary hub. In that case, to establish a successful communication, the robot.cfg file must be updated with the crypt key parameter. Sorry, crypt key parameter, which points to the certificate.pem file of primary hub. So one needs to pick this certificate.pem file from the primary hub machine, which is available here, and copy the same security folder to a remote machine, which is a secondary hub machine. So this is the secondary hub machine, for example, which I am showing you. You need to copy the security folder here and mention the same in the robot.cfg. So we need to mention the same in robot.cfg. If this is not done, what happens is the database connectivity will not happen for the OI connector. So that's the problem, because we are mentioning the data engine address. So the entire JDBC URL and the decryption algorithm and everything will be successful only if and only if the security.pem file is available. So that's the a technical aspect over there. And similarly, for APM bridge also, primary hub address and connect to primary hub parameters must be set if the APM bridge needs to be deployed on robot connected to primary hub. So as you see here, you see the primary hub address. So this needs to be mentioned properly with the forward slash in the beginning, and also the connect to primary hub, which is true. So these two parameters will ensure a successful connection for APM bridge, which is deployed on a remote machine connected to primary hub. Initially, I mentioned about the memory settings as well. So APM bridge is a high performing probe. In-house, it got certified with 45K devices with 64 M of minimum memory and 1 GB of max memory. But recently, from past 1 year or 1.5 year, where we have seen extensive use of APM bridge, and high inventory is not just a computer system. Inventory is configuration item, just like it can be a disk, it can be a physical disk, it can be a logical partition, it can be a network adapter. All these are treated as inventories only. So all these are treated as configuration items under inventory. So as and when it, to an end user, it appears like it's a single machine, but a machine has computer system. I mean, a machine has a disk, network adapter, and etc. All the inventory items. So it's per machine average there are 6 to 10 inventory items which we are discovering. So if the count increases, if there are 100 machines, 100 into 10. So as and when this count increases, we see lot of data in the inventory queue, in the UDM inventory queue. Especially what I am referring to is this particular aspect. So this particular queue. So as and when the number of inventory increases, so we get lot of data into the UDM inventory queue. Now what happens in that case is there will be a spike in the java.exe process, especially associated with APM bridge. So in order to accommodate the higher number of, let us say you have 80K or 60K of inventory, not always this inventory changes, but as and when it comes, the load actually obviously increases. So in order to ease out, we are recommending the minimum to be 2G and maximum to be 4 gig. And of course, now if these are deployed on remote robots, having this kind of setup would actually make things, to work smoother than expected. So now the thing is, if let us say you have in an environment we have 30 to 40 origins. So APM bridge is having a single profile for APM bridge makes it you know uh, hit the UIM API, especially APM bridge depends on UIM API in the backend to get the computer system details. So if the origins, as long as the origins are increasing, a comma separated origins are being added in the configuration section. At a single shot, it tries to bring all the details. So what happens, that is the payload size, the response payload size increases from, it can be for 15,000, it can be almost 100 MB based on the inventory data. 100 MB is very less. I'm talking about mostly 1 GB of data at a time. So at that point of time, there can be an out of memory. So to avoid this out of memory, and we have seen, it's not can, we have seen that out of memory in a couple of occasions. So in order to avoid that situation, what we are recommending is to split the origins across multiple profiles. Let us say if you have 40, make it 20 into 20. So to do so, all you need to do is open the APM Bridge configuration file. Just this can be done only via. I know this one-time admin task, but right now this is the only option where we can do properly. Doing this can be done via raw configure section, but it's parameter by parameter. It takes a lot of time. So all you need to do is just copy paste, make the value as 1 because this is the first profile, this is the second profile. You need to increment the number and only edit the origin. Let us say you have comma separated origins like this. Okay, hub 1, hub 2, hub 3, and so on, like till 40 hubs. Okay, now we don't want, at this point of time, we are splitting. All we need to do is mention 20 hubs here, like hub 1, hub 2, hub 3, and so on up to 20, and so on up to 20 hubs. I'm just, for understanding sake, I'm making it ellipsis comma 20, but yeah, but we need to split in this fashion. So on up to 40. This will be 21. Okay. So in this fashion, nothing, no change. There can be a split again here. Call it as 3. Okay. And from 41 to 60, let us say, suppose this is 41. Sorry. So this is 60 till 60. Hub 60. So in this fashion, what happens is each profile gets associated with a thread. Now each thread is an independent execution. So what happens here is there is a neat concurrency maintained properly, and in a single it avoids a single thread model over there, and the things will work smoother. So we can avoid the out of memory exception. So that's one recommendation. So this is, both this, as I mentioned, we have the screenshot here, how to copy paste and do the things. So both these slides talk about the same information which I have explained. And the last one is time to live. in an organization, it is very much important to hold the inventory data on the DXOI side. I mean, to have the analysis done on the DXOI side, the predictive analysis and creation of services and generation of reports. So all this stuff being done on DXOI side, it is very much important. Like if there are certain devices which on the UIM side, if they are made obsolete, the same has to be reflected on the DXOI. Uh, it's a fair expectation to have a early cleanup as and when there is a deletion happened on UIM. So in order to facilitate that, by default you see Vertex time to live in seconds and edge time to live in seconds is configured as 1 month. Based on your needs, I mean the end user needs, you can configure 86,400 seconds, which is single day, or I mean 15 days or 10 days or even half a day. Just mention the value in seconds. So what happens is every 5 minutes, generally APM bridge runs, the interval of APM bridge is actually 5 minutes. It's a 5 minutes interval. If you see here in the inventory service, the sync rate is 5 minutes interval. So every 5 minutes, this also can be configured if it is observed. This is all based on observations only. Nothing is wrong and nothing is right to have a value 5, or you can increase it to 15 minutes, you can increase it to half an hour based on how much dynamically the inventory is changing and how much data the UDM inventory queue is pumping. So based on that, this value can be adjusted. The sync rate can be adjusted. Now every 15 minutes or every 5 minutes, when APM bridge is trying to sync the data, so what happens is the inventory data which is active is going. However, the time to live parameter, once adjusted, it will try to update on the DXOI side. Meaning once a device on the UIM side is deleted, if the adjustment is made such that the number of seconds, like 1 day, the next day immediately itself, the expiry on the DXOA side happens quickly. So this makes both the systems sync. There won't be any sync problems like, I have more number of data on the UM side, I have less number of data on the DXY side, or vice versa. I have more number of data, obsolete data still showing on the DXY side, and I don't see it in UM side. So the time to live will avoid those kind of issues. So we have made a few enhancements and defect fixes to stabilize the APM bridge probe based on the field issues and also the customer recommendations. So you see the UDM inventory data collects and stores the details of configuration items and computer system inventory in a cache folder. I'll show you. Most of you are familiar, but whoever are new, they can see the location. The APM bridge probe is available in service section of probes, and there is a cache folder which piles up. You see these 1 KB files which are piling up. These are the partial chunk files which are created as and when new inventory is published in the UDM inventory queue. What happens is after 15 days or 1 month from the day APM bridge starts running, there will be huge chunk of data piling up. So sometimes what happens is the persisting of index document in this index file also takes time. Uh, the standard operating procedure workaround is to deactivate the APM bridge, clean up both these folders, especially the cache and store, restart activate the APM bridge again. Both these folders get created. To ease out this, to provide some easiness to this problem, we have provided automatic cache deletion option, which runs every 24 hours. So the noisy files, the partial chunk files, 1 KB or 2 KB, get deleted. And at certain point, there will be this kind of huge partial chunk files which will still be available, and that is valid. They will be available because good amount of data is residing in those files, and every cycle, every 24-hour cycle, uh, the APM bridge makes sure that whatever files, partial chunk files, do not match to this index date. I repeat, whatever partial chunk files which do not match to this index file, and the size of the partial chunk file size is 1 KB or 2 KB, those files will get deleted. Rest of the files will be retained. And every 24 hours, the time is configurable, but the default time is 24 hours. Every 24 hours this happens, and older files which are not matching to the latest index which got updated will and whose size is 1 KB and 2 KB, they get deleted. So on the OI connector side, we have a couple of crucial fixes which we have identified for different customers. So one such problem is, alarms which is coming from the UIM queue having the same status as new, and the same alarm comes out to be with status new, you know from reconciliation. So this is causing for same alarm, for same alarm ID, this is causing duplicate situations on the OI side. Now the fix is available in the latest OI connector, which will be released soon. We have a hot fix also available. On the OI side also, the fix is done. So it's a dual layer fix to be extra careful, so that these kind of duplicate situations do not occur on the OI side. And also a fix is made to honor the user tags. Generally customers are mostly, the end users are mostly interested in the having a user tag associated at the controller level. And also this can be different for a secondary hub. If there is a secondary hub controller has its own user tag, and primary hub controller has its own user tag. To honor the hub level user tags, we have provided a fix that is also that fix is also available in the upcoming release. So these are the best practices and um, enhancement details and fix details from our side, especially for these connector probes.